Okay, we're going to talk about distance equals rate times time word problems. Now, the nice thing about this is the title of the subject is exactly the equation we're going to use. The distance it takes, or the distance you can travel, is equal to the rate in which you go, so usually miles per hour, times how long you travel. Okay, and that's a pretty simple formula, and it's a nice easy formula to figure out some pretty interesting problems. So, for instance, let's take a look at a couple examples we have here. It says 2 cars leave Los Angeles at the same time. One traveling due north at 50 miles per hour, and the other traveling due south at 60 miles per hour. How long will they be? How long until they'll be 330 miles apart? Well, when we come to distance problems, one of the things I like to do is I actually like to just draw a little picture so you can kind of get a little visual. So if you have 2 cars, okay, and one's going to go north, okay, and one's going to travel due south, one's going at 50 miles per hour, the other one's going to go at 60. And the picture doesn't have to be perfect, but at least it's giving you a little bit of a look. Okay, so now what I like to do also is I like to draw a little chart with distance problems. And what I do is something quite as simple as this. Just draw a chart like this, split it in half, and I just write distance equals rate times time. And it's just a visual organizer for you. And so I'm just going to fill in some things. This top line is going to be for my car going north, and the bottom line for my car going south. And so I'm just going to read and fill in stuff that I know. It says 2 cars leave LA same time. Okay? One traveling due north at 50 miles per hour, and the other one traveling due south at 60. Okay, how long until they're 330 miles apart? Well, do I know anything else? Well, I do know something about time. It says that they're traveling the same time. They're leaving at the same time. So therefore, T will be the same. T and T. Now, distance. Now, you might be tempted to put 330 in here, but remember, that's not how far one of them is going. It's how far together they will be traveling. So my question is, will they both travel the same distance? Well, the answer to that is no. So what I'm going to do is I'm going to call the one going north. I'm going to say it's going to travel a distance of D1, and this one D2. And then this is going to create my equations. I'd say D1 equals 50 T, D2 equals 60 T. Now, what do we know about those distances? We know that together they're going to make 330 miles. So that means that these two distances will make 330. Well, I know D1 is 50 T, D2 is 60 T, and so I can solve. That's 110 T equals 330. Divide by 110, and you end up with 3. And what is 3? 3 is the time that they traveled. It says how long will they be 330 miles apart? How long until, that should say. How long until they will be 330 miles apart? It will take 3 hours. And there you go. Is this little chart right here necessary? No. I think it's just a kind of a nice little organizer for you, but you don't have to use it by any means. Okay, let's take a look at another one. It says, at the same moment, 2 trains leave Chicago, New York. They move towards each other at constant speeds. So over here you have Chicago, and over here you have New York. And you got 2 trains heading towards each other. Okay, the train from Chicago is moving at a rate of 40 miles per hour, and the one from New York is leaving at 60. So this one's obviously traveling faster. The distance between Chicago and New York is 1,000 miles. How long after their departures will they meet? Okay, so again, I'm going to just create a little chart. This is my distance, rate, time. We'll say this is the one from Chicago, this is one from New York. So I know some rates. This one's 40, this one's 60. Okay, and it says at the same moment. So that means the time they're traveling is equal. And again, do I know the distances? No. Will they travel the same distance? No, because one's going faster than the other. So again, I'll say D1 and D2. So I have the equation d1 equals 40t, d2 equals 60t. Well, what do we know? We know that the distance between Chicago and New York will be 1,000 miles. That means together, d1 and d2 will eventually travel 1,000 miles. So I can just plug in. So I get 100t equals 1,000. Divide by 100, t is 10. So how long after the departure will they meet? Okay, well, they will meet after 10 hours. Okay, there you go. Okay, so let's take a look at the last one here. Okay, this one's a little different. It says a freight train leaves the station traveling 30 miles per hour. A passenger train leaves 1 hour later. Okay, so you got two trains. Okay, you got the freight train taking off. Okay, going 30 miles an hour. Then you have a passenger train taking off. It's going to go at 50 miles per hour, but it's leaving an hour later. At what time will this train eventually catch up? Well, again, I'm going to create my chart. And as I said before, chart's not necessary, but I like it as a visual organizer. So this is my freight passenger. We know freight's going 30, passenger at 50. Now time this time is different. It says the freight train leaves, and then an hour later the passenger train leaves. So how do we describe their time? Well, if the freight train, if we just call that T, then how does the passenger train compare? Well, it's going to be T minus 1 because it's leaving an hour later, so therefore it's traveling an hour less. Okay? What about their distances this time? Well, their distances this time are going to be identical. Eventually, because you're being asked, when will this one eventually catch up? So their distances will be the same. So I'm going to just call this one D and this one D. So it'll be D equals 30t and D equals 50 times t minus 1. And like I said, their distances will be equal. So I can set these equal to each other. 30t will equal 50t minus 1. So I'm going to solve. 30t equals 50t minus 50. I'm going to subtract 50t to the other side. So I get negative 20t equals negative 50. Divide by negative 20. T equals negative negative make a positive, so that's 2.5. 5 over 2 is the same thing as 2.5. So it will take 2.5 hours for the passenger train to catch up. And there you go. And like I mentioned, I think a picture is a good thing. I think it gives you a visual, kind of gives you a real feel for what you're dealing with. I think the chart's a good thing. I think it organizes your thoughts really well as well as the picture. And then just solving the equation and then actually explaining what your answer is. And that is how you do distance equals rate times time problems.